Okay, here's another problem where the ellipse has been given to us in the form that we don't like. It's possible to be given the ellipse in the standard, in the HK form, in the conic form. In that case, we wouldn't have to bother with completing the square, but we might as well show it for some extra exposure to that. So here we have, again, we want to look at the x terms. So we got 9x squared plus 72x. That's a 72. X, and then we have the y terms, which is y squared plus 6y, and then the 135, we're just gonna like move it over and make it negative 135, subtract 135 from both sides, because we're gonna have to divide something in later. Okay, so what we have here then is we're gonna look at the x terms. We're gonna take out the leading coefficient of 9, so we're gonna factor the 9 out, and then we're left with x squared plus 8x. Okay, leave a little space, plus the y squared plus 6y, leave a little space, is equal to negative 135. Now you have to think to yourself, what do you have to add inside those parentheses there to make this a perfect square trinomial? So x squared plus 8x plus what is a perfect square trinomial? Well, you have to add 16, because you take 8 and you divide it by 2 and you square that. So 4 squared is 16. We didn't just add 16 to the left side, we added 16 inside that parentheses. And so we added as a value of 16 times 9 to the left side. 16 times 9 is 90 plus 54. If you do that, it's 144. So we're going to add 144 to the right side also. Now, for the y terms, what we would have to add to make that a perfect square trinomial, that would be 9. We take 6 divided by 2, that's 3 squared, it's 9. So we have to also add 9 to the right side. Okay, so once we're going to clean this up a little bit. We've got 9 times x plus 4 quantity squared plus y plus 3 quantity squared. And that's going to equal, let's see, what is this? Negative 135 plus 144 is 9, I believe, right? Yeah, plus another 9 is 18. Okay. Well, it doesn't work out to a nice number, does it? Okay, oh well. So now we're going to divide everything by 18, and then we are going to say, when we finish this, we'll put x plus 4 quantity squared divided by 2, because 9 divided by 18 is 1/2, plus y plus 3 quantity squared there too, divided by 18 equals 1. Now center is easy to pull off of this. Again, center is just HK, so center is going to be negative 4, negative 3. In fact, why don't we just put that right on the graph right now? Negative 4, negative 4, negative 3. I know how to count. There it is. Okay, there's the center. Okay, now it's going to be a little more difficult. Well, it's not that much more difficult to find the vertices. Notice on this problem that the number underneath the y term of the ellipse, the 18 here, is greater than the 2. That means this is going to be a vertically oriented ellipse. And so this is going to be an up and down ellipse as opposed to the left and right one that we did previously. So the major axis is going to be the vertical axis. So this b squared right here, this is b squared. B in this case is going to be the larger distance. Now, it's often taught that we always say that the major axis is a. So we say that 2a is the length of the major axis always. I like to teach it a different way. I like it to have the a squared always be with the x term, and the b squared always be with the y term. That way we don't have to worry about which one goes where. And then we don't have to worry about a kind of changing definitions from being horizontal to vertical or anything like that. So we're going to call the 18 b squared, and we're going to call this one, the 2 is a squared. So b squared, then we're going to go, if we went b up and down from k, like this is how we would say generally what this would be, because we had hk, right? But now we're not adding or subtracting from the x value of the center, which is h. We're going to add or subtract from the y value, which is k. So k, and then plus or minus, in this case it's going to be b. Okay, so for this problem then, we would have negative 4, and then b squared is 18, so b is, we take the square root of 18, we get 3 root 2, okay, because that's what it is. So negative 3 plus 3 root 2, and negative 4 comma negative 3 minus 3 root 2. Okay, so those would be the coordinates of the vertices. Now again, this is kind of a unfortunate length, because who knows what that is. The square root of 2, as mentioned previously, is about 1.4-ish. So 1.4-ish times 3 is it's like 4.25-ish. And so if we go 4.25-ish up and down from our vertex, our center, we will be able to put the foci. So the foci are going to be, again, we said it's about 4.24-ish up. So 1, 2, 3, 4.24-ish. We should have a focus right there. 1, 2, 3, 4.24-ish. We should have a focus right there. Okay. So that's that. A is the square root of 2. So if A is the square root of 2, that means we're going to go left and right about 1.4-ish from the center to get to those points. The other information we want to know is where the foci for this. So the foci, again, we have to do a little bit of math here. C squared is equal to the absolute value of A squared minus B squared. Okay, and so we can do this because A squared is 2 and B squared is 18. So the absolute value of that is 16. Right? 2 minus 18 is negative 16. And absolute value of that is 16. So C squared is equal to 16. And then C is just 4. That's much more convenient. So much in the same way we did for the vertices, the corners of the foci are going to be H and then K plus or minus C. So the foci for this one are negative 4 and then negative 3 plus 4, which is 1. And negative 4 and negative 3 minus 4, which is negative 7. So the foci are going to be easier to graph. We would have a focus right there, and we'd have a focus right there. And then the ellipse itself, we kind of sketch that in here. Ooh, so the top of this one is much better than the bottom. So it kind of, it doesn't like come to a point ever. It's a curve. So there's your sketch of that ellipse. I'm really bad at drawing these, as I am at most things, but that should give you all the information we need. And again, it's usually a good idea to actually label where these foci are. So this one is the negative 4, comma 1, 1, and this is the negative 4, comma negative 7 focus. And that's that problem. Let's go on to the next one here. Okay, so this one's a little bit different. Here I want to generate the equation given this information. And whenever you see a problem like this where you're given information about anything, you should kind of draw a little picture to yourself to see if you can get a sense of what's going on in your head. So let's put this information on the graph. This ellipse has vertices at 5, 1 and negative 3, 1. So 5, 1 is right there and negative 3, 1 is right there. So those are going to be the endpoints of the major axis. Those are the vertices. So right away, I could tell you that my ellipse is going to be one of these guys. Okay, it's going to do something like that. The foci are at 3, 1 and negative 3, 1. So 3, 1 right there, and negative 1, 1 right there. So this tells us a lot already about this equation, because if the center of the ellipse is right in the middle of the foci, which is right, and it's also right in the middle of the vertices. So this is the major axis, right? This is the major axis, okay? All of those points are on the major axis, and in the middle of there, that point is obviously 1, 1. That is the center of this ellipse, HK. So remember, we have the HK form, or the conic form of an ellipse is this. X minus a quantity squared divided by a squared plus y minus k quantity squared divided by b squared equals 1. So we already have, boom, we have HK. Okay, HK from our graph is 1, 1. Easy. Okay, we also were given A in this problem. A is just the distance from the center to a vertex along the x direction. So that's 4. So A is 4. So boom, A is 4. We have that. Okay. We don't have B, but we do have C. Okay, C is is this distance from the center to a focus. That's 2. So C is 2. We don't have that. We don't need that in our equation, but we need it to find B. So we already have HK, A, and the only thing left we need is B. So to find B, remember we have the equation C squared is equal to the absolute value of A squared minus B squared. For a left to right oriented ellipse, it's exactly what it says it is. So we can just say C squared is equal to A squared minus B squared. And we just want to solve, we just want to find, we want to find B here, right? So if we solve this for B squared would equal A squared minus C squared. And then, so B would equal the square root of, say, A squared. So that'd be A squared, which is 4 squared minus 2 squared. So that's 16 minus 4. B is equal to the square root of 12. So B is equal to 2 root 3. Okay, 2 root 3 is the square root of 12. So B is 2 root 3. B squared, though, is just 12. Because I don't actually care what B is. I don't really need to graph this. But if I did, I would know that that is 2 root 3 and that is 2 root 3. But I don't care. It doesn't ask me to graph it. So to answer this question, then, all I'm going to do is just write all this stuff and know where it goes. We have x minus h. We said h was 1. Quantity squared divided by a squared. A was 4, so a squared is 16. Plus y minus k. We said k was 1, so it's just 1. And then b squared, we just said was 12, and that's going to be equal to 1. And that's it. That's done. So these kind of problems are real nice. If we draw the picture, we can determine all the information about it. Let's do one more like this. All right. We want to find the equation of ellipse that has vertices at 0, 5, and 0, negative 5, and contains the point 3,2. Okay, so this is a little bit different. I actually haven't done this problem before, so hopefully don't mess it up too bad. So let's put in the information that's given to us. It says there's a vertex at 0, 5. So right here, is that 5? I can count 1, 2, 3, 4. So right there. So vertices are there. If the vertices are above and below each other, that means it's going to be a vertically oriented ellipse. So also the point 3,2 is on it. So let's put that point 3,2 right there. So this ellipse has to do something like this. Okay, it's vertical. Does something like this. Okay, that's the ellipse we're dealing with. So it's vertically oriented, and what we haven't been given that much in this problem. So let's write the equation of this and see what have we been given. First of all, we know that this distance right here, b, is 5. So b is 5. Which means, b squared is going to be 25. So our y term of our ellipse is going to have 25 underneath it. Now, the standard form of ellipse is x minus h, or the hk form, or the conic form, divided by a squared. We don't know what happened to that a right there. Fix it. A. Okay, plus y minus k, quantity squared, divided by b squared, equals 1. So what are we given here? Well, the other thing that we can find from this problem is the center of this ellipse. The center is at 0, 0. So HK is 0, 0. So that's nice. So if I look at all these things I don't know, right? I know there's a point, we put this point right here, XY, right? This point XY is at 2, 3. If I knew any point XY on this ellipse, it would substitute in for this x and this y, because that's what this equation is. If any value xy that satisfies these conditions, and that falls on this curve. So I know in this case, let's put in green the things we know. We know x, we know y, we know h, we know k, and we know b squared. So this is an equation with 1, 2, 3, 4, 5, 6 unknowns, and we have 5 of them. So all we need to do is solve for a squared here. So let's do that. We don't have to, if you want, you can rearrange everything and solve for, actually, is that going to be difficult to do? I don't know. So let's just plug the numbers in and then we'll just solve. So we'll have x, so we'll have 2, I'm going to use a different color for this. You could rearrange this whole thing algebraically to solve for a squared, but this is not, I don't think the juice is worth the squeeze for this particular problem. So let's plug in all the stuff we know. We know that, I'm going to use green, I'm sorry. We know that x is 2 minus 0, h was 0, quantity squared, divided by a squared, again we don't know a, plus 3 minus 0 quantity squared divided by 25, that equals 1. Okay. Now we'll simplify this a bit and then solve for a. So we'll have, it's going to be 4 divided by a squared plus 9 divided by 25, 9/25 is equal to 1. So let's move the 9/25 over first. This will be 4 divided by a squared is equal to 1 minus 9/25. Okay, we'll rewrite the 1 as 25/25. So there'll be 4 divided by a squared is equal to 25/25. That's just rewriting 1 minus 9/25. So then we'll have 4 divided by a squared is equal to 16/25. We can like cross multiply stuff here if you want. So what we end up with is a squared, 16a squared is equal to 100, right? And so a squared, if we solve for it, is equal to 100 16ths. Obviously, this simplifies the greatest common multiple between 100 and 16 is 4. So this is like 4 times 25 and 4 times 4. Okay, so the 4's will cancel. So we say that a squared is equal to 25/4. That's all we need. We don't really care about a itself. If we did, we could square root this and get that a was 5/2. But we don't really care about a. And by the way, if a was 5/2, that means that's sorry, not 5. Yeah, a would be 5/2. So we would have the point. Oh, I totally put this point 23 in the wrong spot. Man, I'm not getting a graphing. Sorry about that. Oops. The ellipse was wrong anyway. So 5/2, something like this. So a ended up being, when we said it was 5/2, like yeah, it's 2.5, right? That's 5/2, so that would be a. But again, that doesn't matter. We can just write the equation now, and we can write this in a couple ways. We can say it's x squared. Okay, hk is 0, so there's no h, so it's just x squared divided by a squared, which is 25/4, plus y squared divided by 25 equals 1. We can also, instead of dividing by a fraction here, we can multiply by the reciprocal of it. So we could say this too, x squared, or 4x squared divided by 25 plus y squared divided by 25 is equal to 1. That's another acceptable way to write it. It depends. Ask your teacher for what their preference is on that. But that's how you would do a problem like that. You just plug in the numbers, all the information that's given to you. Sometimes you have to do a little bit of sleuthing to figure out what information has actually been given to you. Anyway, I hope this video has been helpful. I will check out my other video on other videos on the other conic sections. Hopefully those are also helpful. Let me know if you have any questions. You can leave a question in the comment and I'll try to get to it as soon as I can. Thank you for watching.